We're looking at a functions problem from IB Maths AAHL, and this is one where it's a very funky function, but we have a calculator, so step one is always going to be just graph it. So that's what I've done here in Desmos, and I've given you the output here, but you should be able to see this in your graphing calculator, and I've taken the liberty as well of marking some of the maximum points. So it says the kth maximum point on the graph of f has the x-coordinate at xk. K is going to be a positive integer, and we're saying given that the x value of one of those maximums is equivalent to the previous maximum x value plus d, find d. Now, if we have a look at our graph, the x value is 2 for the first one, and then 10, d is 8. And actually, according to standards for this course, you actually don't have to do anything more for this. You have to say by GDC and explain yourself a little bit, but that would be sufficient. However, I think for the sake of practicing, and it's not too difficult, we can take a derivative and we can find the maximums ourselves and explore why this is true. So we are going to do that because that was no fun. So if we take a derivative, as usual, our why am I putting a 4 on the top? Our sort of e to the whatever stays as it is. But then we have to apply chain rule. The derivative of sine is just cosine. So this becomes 3 cosine pi x over 4, and then we're going to have the derivative of whatever's in here as well, which is now pi over 4. So we get to this position. Now, if we're thinking about trying to find the maximums, this is going to be equivalent to 0, and we look at the pieces of this fairly complicated derivative, we'll notice that e to the power of 3 sine pi x over 4, that cannot equal 0. There's no power I can raise like a normal number to that's going to make it equal to 0. Pi over 4 similarly is just not going to equal 0. The only part of this that plausibly can equal 0 is cosine pi over x, like pi x over 4. So this is what we're interested in. And if we think about, what our cosine graph looks like, I always love a graph. You probably know this by now, right? But when is this graph equivalent to 0 normally? Well, it's normally equivalent to 0 at, this would be pi over 2, and then it would be every pi, right? So we're going to have 3 pi over 2, 5 pi over 2, and so on. All of these values should be points where we're going to get a maximum. So pi x over 4 is equivalent to pi over 2. This is my preferred way of doing this, right? Instead of transforming my function, I know that this entire thing should be pi over 2. So we just try and get a solution. Well, x equals 2 works, and that's pretty convenient because that's our first value. If we continue to look for the next value, this should be x equals, let's see, multiply everything out by 4, and we're going to get entirely x is 6, and then our next value would be 5 pi over 2. That's going to be equal then to, this is 10 pi, x is 10, and you can see our alternating values are going up by 8. And you can also see why this is happening, right? We're supposed to be going up in increments, and we think about this sort of alternating increments over what our x values are. If we just write some out, right? 5 pi over 2, and then we're going to keep adding, right? So it's 7 pi over 2, and then it's like 9 pi over 2, 11 pi over 2. And our maximums are alternating intervals, right? Because we have those minimums. So how are we going up by these each time? Well, it is literally just we're adding 8 to get between them. So that's where those values are, or like that's how much we're going to have to like adjust in order to get the x to make that gap, right? Because the gap that we have physically here between these two is 2 pi, but our adjustment is like pi over 4, right? So it's like the period divided by pi over 4, and then that just gives us 8. So that's why we're getting that regular increase. None of this work is necessary in any way, but it's interesting to sort of see how this is happening, right? Now, if we answer this next bit, this is actually a fairly straightforward sum, right? We're being asked to find the value of n such that the sum of those x values is equivalent to 992. So if we think about, 992, that's our total. What's our first x value? It's 2. And then we're adding increments of 8. So we want our sum of an arithmetic sequence. That's going to be n over 2. And then we're going to have like 2 times 2 plus 8 times n minus 1, just our sum for an arithmetic sequence. And we can kind of work this out. This is 4. That's going to be minus 8. So we're going to have like 8n minus 4 in here. And n over 2. And then we're going to have basically 4n squared minus 2n. And this is going to equal 992. And at this point, I mean, honestly, you could have done this earlier, but we have a calculator. I'm just going to graph this. So let's go over here. Not this. Over here. And we're going to have 992 equals 4x squared minus 2x. Where are our solutions? Well, we have 2, right? We've got one at this like negative 15.5. That's not super helpful to us. Our solution that is helpful is n equals 16, and I'm just going to put by GDC, just to indicate where this is all coming from. But that should be our answer. When we get n terms, that's when we're going to have our full solution.